All right, in this video, we're going to look at finding z-scores that correspond to a given area. So we're going to be working backwards from what we did in the previous couple videos. So again, just in this case, instead of finding the area knowing what the z-scores are, we're going to find the z-scores knowing what the area is. Again, we're going to use the same program, and I will have a link in the description to that program. But again, if you have other technology that you would like to use, by all means, go ahead. So keep in mind, though, that if you are using other technology, that most, but not all of it, is going to ask you for the area that's to the left of the needed z-score. So you might have to adjust things a little bit with your input values. We're still going to start each of these by getting a picture so we have a better idea and understanding of what we should have. Again, as far as the pictures are concerned, they're just sketches. I know these are computer generated, and I try to make them as accurate as I can. But in general, if you're sketching these by hand, they don't have to be perfect because chances are your teacher or professor or whatever is not going to be grading your sketches. At least I never have. So example 4, we're going to find the z-score, which has the given area to the left of it, round to 3 decimal places for the z-score. All right, so we want to find the z-score that has an area of 0.05 to the left of it. So it'll look like this. So what's z-score will have an area of 0.05 to the left. So we're just going backwards from what we've done, actually what we did in the first video. So in other words, if it has an area of 0.05, that means it's in the 5th percentile. So 5% of all the other z-scores are going to be less than the one that we're trying to find. And so to do that, if we go back to our program, this time we're still working with z-scores. All right? In our next section, we'll work with observed values. So I broke it down by section here. So we're still working with z-scores, so select one. But this time we're given an area and we need to find a particular value, in this case a particular z-score. So now we're going to select option 2, press enter, and we have the area this time that's to the left, so we want option 1. So a lot of this is very similar to what we did in previous videos. So please enter the area as a decimal, so it was 0.05, and then press enter, and then we have z equals negative 1.645 has an area of 0.05 to the left. So negative 1.645 for our z-score there. So if you're about 1.645 standard deviations below the mean, you're in about the 5th percentile for a normally distributed data set. So again, since the area to the left of that is about 0.05, we'd say that a z-score of that is in the 5th percentile. All right, what z-score is in the 90th percentile? In other words, that 90% of all the values would be below that particular z-score value. So this time we're going to enter in the area to the left that's 0.9 instead of the 0.05 here. So let's go z-scores. We're working with z-scores. We're given the area, so we option 2 here, and it's area to the left, so option 1. And then what is that area? Well, we said it was 0.9 or 90th percentile as a decimal, 0.9. And we get z equals 1.282. So a z-score of about 1.282 is in the 90th percentile. Example 4 here, part C, find the z-score which is a given area to the right of it. So this time we're going to the right of 0.3. So in this case, if 30% or 0.3, 30% are above this z value, that means 70% are below. So this would be equivalent of finding the z-score for the 70th percentile. So a couple different ways you can approach these problems, but we'll just go with the information that we have. So we have 30% above, so we're working with z-scores, option 1. We're given the area, so 2. And this time it's the area to the right, so we're going to select option 2 this time and enter in 0.3. If you accidentally entered in area to the left, just instead of 0.3, you would use 0.7, so the complement. So here we have a z-score of about 0.524. So a z-score of about 0.524 has an area of 30% to the right of it. All right, part D, the area to the right is 0.5. Well, hopefully knowing about the symmetry of the normal distribution, you can answer this one without having to type anything in. So let's see if your answer is right by typing something in here. So we're doing z-scores. and we're given an area. This time it's area to the right again, and this time the area is 0.5. Hopefully your answer is correct, and you said it was 0, because if you're the average, then half of them are to the right, the other half are to the left. So hopefully you thought z equals 0, and it confirmed your answer. All right, example 5, find the z-scores that separate the given middle percent of the data from the other values. So the middle 50%. So what z-scores will the middle 50% of your data values fall between? So again, we're working with z-scores here, and we're given an area, so option 2. And it's the area between two values, so we're going to select option 3. And enter the area as a decimal, so it's 50%, so 0.5. And we have z equals negative 0.674 and z equals positive 0.674. And because of the symmetry of the normal distribution, in the middle, it'll always be the same value, just with different positive versus negative. So for the middle X% of the data, you will get two values that are opposites of one another. So plus or minus 0.674. All right, part B, the middle 95%. So 95% in the middle. What are the cutoff scores for 95% in the middle? So once again, we're working with z-scores, and we are given an area, so option 2. And it's the area between the two values, option 3. And our area between, we said, was 95%, or 0.95. Again, please make sure it is a decimal. And we get about negative 1.96 and positive 1.96. So our z-scores are plus or minus 1.96, which we will see again in future videos. So that's a pretty popular value there. All right, part C, find the z-scores to separate the middle from the remaining 20%. So this time the 20% is outside. That means there's 80% inside. So one way is to enter this in with 80, but again, we also have the value, the total area outside the two values as well. So again, various options you have available to get the same answer. So we're working with z-scores again, and we're given an area, so option 2. And this time it's the area outside the two values was 20%, so we can select option 4. And the total area outside is 0.2, which is negative 1.282 and positive 1.282. So plus or minus 1.282, which again is what we'd get for the 80% in the middle, which I think we've done already. I'm just going to, because I don't want to scroll through it. 1, 2. This time we look at the area between the two values, the 80% that's in the middle. We should get the same answer. So, and yeah, there they are, negative and positive 1.282. So again, I'll link that program in the description if you want to use it. If you have other technology that you're more comfortable with, use that. But that about does it for this video. Thank you for watching. I'll see you next time.